Really excited to introduce Jason Jerald, who is the CEO at NextGen Interactions. He serves on multiple advisory boards and has been creating VR systems and applications for over 20 years for over 70 organizations. I'll let him tell you about those, but most recently he's authored numerous publications, most notably the best-selling book, the VR book, Human-Centered Design for Virtual Reality. Jason Jerald.
All right, thank you. Can you guys hear me okay? Yes? Okay, well, yeah, thanks for the introduction. So, yeah, NextGen Interactions is my company. I've been doing this for a while. It's been a freaking awesome journey. I didn't know if it was better or worse at times, but it's been quite the trip, and I think it is turning out to be quite worthwhile. And so let's see if I can get this clicker working. Okay, so some of you maybe know me personally or know me best for, probably best known for my book that Jason had mentioned, the VR book, Human-Centered Design for Virtual Reality. Specifically at NextGen Interactions, we focus on customized VR simulations and training those solutions, working with some really great clients. And we learn as much from those clients as I'm sure they learn from us. We're founded in 2012, and we're on the East Coast. Any East Coasters here? There we go. Okay. Well, we all know that virtual reality is sort of this multimodal experience. And as an industry, we've all gotten really good at creating those audio and those visual cues. We've also actually gotten pretty good at proprioception, right? Bringing the body into these simulations so it feels like you're there. It just doesn't, look like you're there and sound like you're there. The proprioception is that sense, kind of internal sense of where your body parts are located. And then there's been a lot of research on the haptic side. Haptics is the technology that allows you to feel things, whether it's virtual reality or outside of virtual reality. However, that's largely been more on the research side. You don't see that a lot, at least in consumer VR, other than simple buzzing in the controllers and such. And so that's what this talk is going to focus on, is that touch, those physical interactions of interacting with physical props and real-world equipment. And so this work was largely inspired, I see that my hand keeps bumping that there, was largely inspired by work done at the University of North Carolina, where I was a graduate student back in the 2000s. And this was a really compelling experience for different reasons, but in my opinion, one of the main reasons is because you could reach out and touch things, right? You could reach out, touch cabinets, you could feel the walls, and what would happen is you'd have this experience, you'd reach out and touch things, then we'd open up a door, you'd walk into the next room, and there'd be a big hole in the floor. Now, logically, users knew, of course, there wasn't really, we probably didn't, put a hole in the floor. But viscerally, it felt like it. In fact, some participants would refuse to go onto what we call the diving board there. And when they did, we ended up adding, we didn't do this initially, added about 1.5 inch piece of plywood there where you could put your toes over the edge. And that was quite a freaky experience because logically you knew it wasn't there, but boy, you sure felt it was there. And so we take these physiological measures, such as skin conductance and their heart rate, and then change things up and see how that would affect things. So we look at things like latency, frame rate, what they're touching, those sort of things, and see what happens. And as a result, some of the thought leaders of the time, like Jerald Lanier, who coined the term virtual reality, he created that back in the 80s, but it really hadn't reached the level, of course, he wanted it to be, and he said this is what he always thought virtual reality would be like. Our Randy Posh, known for the last lecture, maybe some of you are familiar with, he says there's this VR demo and then there are all other demos. And so this demo of this pit experiment, whether it had physicality or not, was really replicated at various conferences and labs and such throughout the world, and has actually been popularized more recently with Ritchie's plank experience. Has anyone tried that? Only one. Well, you got to try it if you haven't tried it yet. It's just a standard Steam VR demo, except you have a physical plank that you match up with what you're seeing. A pretty, basic, straightforward experience, but it adds just so much when you walk on that plank, right? Because you feel like you're going to fall off that plank into the void. So consumer VR has really pushed the technology, caused it to go mainstream. Pretty much everyone knows what virtual reality is now, even if they haven't tried it. It's sort of, people kind of get it, right? They've experienced it very often, whether it's, simpler form of Google Cardboard to the better systems. And that technology has been targeting a mass audience, which is great, but the challenge is for specific needs, it's not always a good fit. That is, they don't convey, for example, that sense of physical touch if I'm going to reach out and touch something in the real environment. And for actual training, that can be a problem, because if you're training with something virtual, I reach out and turn a virtual dial or whatever it is, if that physical dial doesn't exist, you might be mistraining, what's known in the training community as a training scar. And if you practice that over and over again, you're going to get really good at that in the virtual representation. Then you go do it in the real world and it's not quite the same. You're going to be doing it wrong. And if you do it wrong in a dangerous situation, that's going to be a problem. And so not all training, depending what you're trying to do, is sometimes you want to abstract things out, but ideally, in many cases, you want the highest fidelity you can have. So Ivan Sutherland in 1965, one of the pioneers, really one of the grandfathers of virtual reality, he said the highest fidelity system, a virtual bullet in virtual reality, would be fatal. So I'm not saying we want to go that far, but that's how far, maybe you could take it. Not today, but I guess in the Matrix, or a couple hundred years out. Not necessarily that we want to do that. And so you can kind of break down fidelity in different areas. Here's a few examples of different types of fidelity. And here the point is we want to focus on that last one, the interaction fidelity. And that's the degree that your physical actions in the simulation correspond to physical actions for the equivalent real world thing that you're being trained for. And so you can have that low interaction fidelity at the top all the way to the high interaction fidelity at the bottom. Now the point here is not that you always want to go for that high interaction fidelity. In some cases you don't need that and you don't want that. You want to abstract that out. If I want to go check out a library in a virtual library, right? I don't have to walk to that library and look it up and walk down the aisle. I just want to push a button and have the information that I want come up. And so in that case, maybe you do want that non-realistic interaction fidelity. If it's actual equipment that you're going to be manipulating in a very specific way, then you probably do want that higher interaction fidelity. Now, I've seen some pretty amazing hardware throughout the years. However, there's one piece of hardware that I think is pretty essential for virtual reality simulations, at least for the interactive forms of virtual reality. Passive virtual reality, maybe not so much. But it's a pretty essential, pretty amazing device. Fortunately, this technology has been around for quite a while, and it's quite mature and very refined. Any ideas what I might be talking about? I was supposed to make you guys work for that. Yes, so it's kind of hidden in the slides there. So yes, great answer. So the human hands, good answer. So yes, any hand tracking technology is simply a way to bring the hands into the simulation. But not just the hands itself, right? How the brain, is wired up to those hands. And so a large part of the brain, the motor cortex and the sensory cortex is dedicated to the hands because it's so important, right? It's evolved over the eons. And so an example of some of the subtle challenges, I thought I'd have you guys do an exercise to kind of get a feel when something isn't quite right when you're doing these interactions. Maybe it's hard to kind of know exactly what it is, but it just feels off a little bit. So if you guys want to go ahead and clasp your hands together, and notice that one index finger is laying on top of the other index finger, right? There's only two ways to do it. So in my case, my left index finger is overlaid on top of my right index finger. Now go ahead and unclasp your hands and reverse that. And so now my right index finger is on top of my left index finger. Does that feel any different? It feels kind of odd. It's not obvious why, other than, you kind of just did it, and I told you to do that. But it's not obvious why it's off. And so that's an example of the user experience challenges of integrating physicality into these simulations and making it feel right instead of being distracted by, oh, something that isn't quite right. And so bringing these hands into the world, there's been a sort of debate of, do you want to use the hands just by themselves without controllers, or do you want to use controllers? And I think sort of the industry in general kind of wants to go towards bare hands, right? Because there's advantages to that. But there's pros and cons to each. And so the answer of what you use, of course, is it depends. Controllers are highly reliable, at least if it's good tracking technology and such. If you push that button, it's pretty much 100% of the time the system's going to know that you push that button. And then you can add, simple haptics, buzzers and such to those controllers. In some cases, that controller can act as a physical prop, right? If you have a sword or a lightsaber, you want a handle, right? It'd be weird without having that, holding on to something. Bare hands, however, are good when you want to reach out and pick something up, right? If I want to pick up some real world object like this water bottle, I don't want to have to set down the controller in order to pick that up. I just want to reach out and pick the thing up. As computationally intense, although not too bad, as it's been shown that on standalone headsets, hand tracking works pretty darn well. There's physical challenges as far as just the reality of the world. If your sensor doesn't have a clear line of sight or it's outside of what the camera can see, sorry, we can't do much with that. It's not, the hands are not going to be tracked. And lighting and such adds to those challenges as well. And then determination of intent, right? Body language is not an exact science. The system, even if it's that ideal system, it doesn't know what you actually intended. Maybe, I'm not making a tight enough fist. It thought your hand was still open a little bit because it was open, right? You didn't do the full thing that the system was expecting. So again, trade-offs on both of these, neither one is the right answer. In all cases, it really depends what you're trying to do. And so that brings up the question, what should we use? And of course, the answer is, my favorite answer, nobody likes it when I give this answer, is that it depends. However, there's another answer, at least in some use cases, is, well, why couldn't we do both? Right? And some of the controllers are doing that now with those capacitive sensors and such, that as your fingers can move, it can detect how your sensors are holding the device, even though you're using that controller. And so that works well, but if you set the device down, then you might lose that hand tracking. Again, for some use cases. And as far as haptics, you can kind of think about haptics, the touch technologies. They can be divided into passive versus active haptics. So active haptics means that the computer is controlling it, whether it's a buzzer or it's some force feedback or a robotic arm to move that physical thing throughout the world. Whereas passive haptics is about, it's not really doing anything. The computer is not controlling it. It might be tracked so that the tracked object influences what you see visually, but the computer isn't doing anything with that device. So that would be a passive haptics. And then it can be tracked or untracked. For example, in the University of North Carolina demo I showed earlier, or those screenshots, most of that stuff didn't even be tracked. It was static objects. Once they were set in place, once it was properly calibrated, you didn't have to worry about where it was. Obviously, in some cases, you do need things tracked, however. And then, is it world fixed? Is it in that environment, or is it attached to the body? If it's attached to the body, you don't necessarily need it tracked. For example, if you have buzzers on the belt, then as you move through the environment, maybe you don't care where they're located. You just give the guy, some cues of something's going on. So you don't need to track that. Okay, so now on to some use cases. So one of the most compelling use cases we found was air monitors for hazmat specialists. And this was not our idea. When we first started working with firefighters, we thought it's sort of the stereotype things of fighting fires that you see in a lot of demos. It turns out that wasn't really, there wasn't too much of a need for that, at least with the firefighters we were talking to. But we found out that hazardous materials, there's a big problem with training. And so it's typically done in a classroom environment similar to this. And if you want to take this device out in the field, would you guys feel, confident if you had a, 30-minute lecture of me telling you about the technicalities of this device? Probably not. In fact, when the firefighters actually get out on the scene, these are pretty much available on every fire truck. Those firefighters have been trained how to use that. Problem is, they're not confident enough to actually use it, so they call up the hazmat specialist, which can add minutes, sometimes worse than that, of waiting for that hazmat team, and bad things can happen when you just are waiting around for the specialized teams to come into play. Now you could take this device, of course they're going to show you the device, they could pass it around the room, but it's not like you can take this device and go around the room and, oh, there's gas over in this corner, I see how it changes, right? Unless you're actually going to emit those gases into the environment. And even in live action training, the trainer typically reads from a piece of paper of what's going on, what the different gas levels, what the situation is, essentially giving away the answer, right, by questioning about those specific answers. So it's difficult to train for situational awareness and such. And so experience is only gained from actually being in those rare and dangerous real world incidents. And those are extremely rare in this case, at least when they get really bad. You might not have one of those incidents for years at a time. And thus it can take years to gain that experience that's needed to get good at using these things. Whereas for VR, right, you can train not only use of the device, but in the context that they'd find of those dangerous situations. So you can train, you know, almost immediately versus taking years. So here's an example of bringing in a real air monitor into our simulation. We just added a tracker onto it, and then we intercept the button presses there. And then the system knows when you're pushing the buttons and such and moving that device, as you can see on the right, throughout the environment. We also 3D print props and add, these are Steam VR sensors, Lighthouse compatible sensors, along with our own buttons. And the point here is if you do this, you could change it up, right? If you wanted to modify this, this device and, you know, try things different than what's currently available, you can mock that up and make modifications after actually using it in the simulations to inform the next version of the device, which is, you know, not straightforward to do that, but more straightforward than actual building a real air monitor, right? You can do that more efficiently and figure out where it works, where it doesn't work before committing to the full thing. And so here's an example video.
Okay, we've got our orders. Let's go get the gear ready and head down range. Go ahead and grab your air monitor. Turn it on by pressing the red power button on the right. Once that powers up, you'll see 4 sensors on the screen. As I'm sure you know, those are oxygen, LEL, CO, and H2S. Go ahead and do a quick bump test by putting the meter up to the test cup attached to that cylinder. It's filled with the calibration gas for all 4 of our sensors. Looks good? Then let's head out to the hot zone.
Okay, so it continues on. You actually ride out to the incident site, and then you can practice using that air monitor in the context of the incident. And so we played a lot with different props. So example here, we just tore a trunk out of a car found in a junkyard, and then attached a puck to the wheel well lid. And the idea is that we can kind of do some basic things with explore the searching a vehicle physically. And so we don't need to track the back of the trunk there, we're just tracking the lid. And you can see you only need to model what is actually they're going to touch, right? What I mean by that, I mean physically model, right? It's not like we need to model physically build the entire car. We do that visually, right? Because they're not actually going to walk over, in this case, and touch the front of that car. And this led to the discovery of a device that's now coming to market for security checkpoints of a backscatter device. Basically, this is a low energy X-ray device that you can carry around and look inside cars and see organic material and be able to see through that car. And so the idea here is that we can simulate that and refine those processes and such and train the usage of that for a drug search without having to tear apart the car, which is how it's currently done. Here's an example of a fire truck pump panel. You can see on the left side, we've been playing with different buttons and levers, dials and such. And then in the middle, you have a virtual representation matching up with that pump inside our office that visually matches our real world office. And then we can put that on an actual fire truck. Now they have these actual pump panel simulators in the real real world and classroom settings and such, but you can't put it in context. You can't put it on the side of a fire truck. Now, one way they do training as well is they actually train on a real fire truck. The problem is if they get a call when they're training the new guy on this pump panel, then they got to reconfigure that pump panel before the fire truck can get out of there. And the stereotype of, when there's a fire, you move quickly. You don't wait for someone to reconfigure your pump panel. Here's an example of an Armband interface where we added, in addition to tracking the device, we added a touchpad. And the idea here is this is a controller, but leaves your hand, a VR controller, but it leaves your hands open, right? So I could pick up this water bottle without having to set down the controller. And so here we have a triage scenario example, really just exploring, talking to EMS personnel and such of how this might be useful. The idea here is that also that you can interact with this similar to a controller, right? You don't have to look at your controller as you can kind of hold your hands down to the side. And so a real world device you could, which might not even be virtual reality. This might be for a real product, but the point is that you can prototype and figure out what works, what does not work here. So lessons learned. The big one is you got to work, of course, with your customers, with your SMEs, not just in designing the project, but in the learning objectives, but actually sitting down with them. Our platform, we have formative usability evaluations. It's collecting objective data, but also subjective data with timestamps and such, so that we can go back and we can figure out what worked, what did not work, but also sitting down and them telling us, everything we're doing wrong. And, oh, you need to move this over, to the right. A firefighter's not going to understand that. And I also want to emphasize, we're not trying to replace all real-world training. In some cases, real-world training is just fine, right? Don't try to fix it if it's not a problem, but really figuring out where is it useful and not completely try to replace that. Steam VR Lighthouse tracking has its challenges. Calibration is a huge challenge, and we've kind of come to the conclusion it's probably not the right solution for physicality. And so for other projects, we've used the anti-latency tracking system. Maybe some of you are familiar with space-based tracking, OptiTrack, etc. And I want to emphasize, physicality isn't a good fit for all VR projects, right? That adds complexity. You want to keep things simple unless it's needed. And so we do things both, some of our projects we don't do physicality at all. It really depends on the use case, so you want to target those use cases where it's important. And so the best use cases we think is where interaction fidelity is important, and you're interacting with physical equipment, and that training is difficult to replicate in the real world. Otherwise, why not just do it in the real world? Why go to all this trouble? And high-risk, low-frequency incidents. The firefighters, for training, that's like their mantra. That's what they need to train for. They don't need to train for the things they do every day, because they essentially are training for it by doing it every day. And so those things that may only happen once a year, but if it goes wrong, boy, it goes really wrong. And so you want to be prepared for those crazy bad situations. And so we probably primarily have been working with public safety, but other industries we identified, obviously military, but nuclear, oil and gas, and space operations we also think could be a good fit for physical VR. Okay.
We'll take a couple of questions.
Absolutely.
Okay, we have a couple minutes for questions. Thank you, Jason. Really fascinating. I one of my first jobs was at Apple Computer 30 years ago. We were working on speech recognition, and it was about 94% accurate, which meant it was completely unusable. So thinking about like the HoloLens too, and some of those interactions when you deal with hands, do you have an idea, like some comments on that reliability of interface and the importance of that?
Yeah, I'm actually, I used to be pretty skeptical about that because of that exact reason, but it's gotten pretty good, again, for some things. If you need those very precise things, or it's important where it's 100% of the time, but if you're doing these gross, actions like a really large button, right, you don't need the precision. But the finger point precision, and it needs to be right 100% of the time, of not clicking it twice, it can become pretty frustrating if it doesn't work all the time.
Imagine a mouse that misses 1 out of every 20 clicks.
Yeah.
Yeah. Questions? Sure.
Hello, my name's Andrew Thompson. I'm with Lockheed Martin. A lot of our use cases in VR is like we're trying to assemble something and trying to reach into a bay before we actually do it in production to make sure that we can actually do that. We've been having problems with like trying to show an actual hand and doing some of that stuff. I was curious if you had any tips or any recommendations of how to actually show a hand in the VR space.
So showing your own hand or reviewing it in hindsight, or in what sense?
Yeah, in like real life, so calibrating your hand to be somewhat realistic. And so I've seen some stuff that's been around here, so like Manus or Haptics does that. I think in one of your videos you showed a hand in there. I was curious what you used and if you've been successful with that.
Yeah, so we've used different gloves, the Manus gloves, for example. We use Leap Motion, Oculus Quest. We really try to be sort of hardware agnostic, but they all have their advantages and disadvantages. So gloves, for example, work great because, you know, the hands can be back here. You don't have to worry about if the sensors see them. But, you know, if you're doing this sort of finger point accuracy, it can sort of be a challenge. And to get that really reliable, consistent hand tracking is still a major challenge because there's just physics involved, right? Unless you have a bunch of cameras, it's hard to see the hands from all different angles and, you know, see beyond the hand, for example. So sorry, I don't have a good answer for that. I will say one thing that we think is really valuable is after action reviews. So, you know, maybe not the perfect hands, but be able to go back and review yourself or watch an expert, right, with those after action reviews from within VR. So you could, you know, look in the hands sort of in hindsight, but it's not going to be, you know, the absolute truth of those hands.
One more question, real short.
Sure. You explained that you had the props that you were making, sometimes low fidelity props like the plank, for example. What about more generic marker-based props like a merge cube? Have you had any success with those?
Yeah, absolutely. So we worked with Merge on a project called Dino Digger. So it was sort of an educational application. And, you know, similar challenges. It's not going to be perfect all the time, but, you know, at times it does work really well. And sometimes, you know, in some cases you can guess, right? So when for example, camera-based solutions for Leap Motion, for example, they specifically say it's not built for physical things. Don't bring in physical things. So what do? Of course, we try to bring in physical things, do what they're trying not to do. So we use different tricks. For example, if the hand's in the general vicinity and there's one way to grab the object, we can assume they're going to grab it in that way, and then we can interpolate to that grab. And it gets it, you know, might get it right 90% of the time, but if they grab it in a different way than they're supposed to grab it, then, you know, you want to be careful of those assumptions. So, you know, it kind of depends what you're trying to go for, and depending if the trainer, if the user already knows how they're, you know, should be grabbing it.
Jason, thank you.
Thank you.